Okay, this is a quick review of covalent bonding. This is part one. And I just want to establish that covalent bonding is when you have a sharing of the electron between two elements. For instance, hydrogen and chlorine, hydrogen chloride. Okay, and this is going to be in the gaseous state. This particular element, this particular molecule, covalent bonding, is gaseous, G for gaseous. That'll become important later on. It's not hydrochloric acid, it's hydrogen chloride in the gaseous state. So, however, with covalent bonding, you have a sharing, okay? And that sharing can be unequal. Where chlorine is more electronegative, it will pull the electron cloud that is between the two elements to the chlorine side. And you'll create a slight negative charge on the chlorine side, a slight positive charge on the hydrogen side. And this shift towards the chlorine of the electron cloud is indicated by a line with a little hook on the left side, and that's called a dipole moment. And this is called a polar bond. A polar bond is any bond where you have a dipole moment. Any bond where there's a shift in the electrons toward the more electronegative element, that's called a dipole moment. For instance, if I had hydrogen, okay, electron there, that's a perfect sharing of the electrons, a perfect sharing. There is no dipole moment there because they have equal electronegativities. So it's a perfect sharing. So this is not a polar bond. This is a non-polar bond. Any of the diatomic gases, for instance, nitrogen has a triple bond there. That's also non-polar. Even though there's 3 bonds there, it's still non-polar because there's no difference in electronegativity. There's no shift in the cloud. Here there's a shift, a dipole moment, polar bond. You have to know what a dipole moment is. You have to know what a polar bond is. Remember, covalent bonding is a sharing of the electrons between two elements. We're off.